Good morning everyone. I am Tanushree from Civil Engineering branch, and today I am going to teach you your Theory 2 paper which name is Structural Design 2. In the last class we discussed about design procedure of tubular section for compression member, and today we will study about the design procedure for truss member, where both compression and tension member you have to design. So now for the truss member we have to design the compression member. After that we have to design the tension member simultaneously. So first of all, for the compression member design, the procedures are given here. So in step 1, first of all, we have to write down the data given. Basically, in the question, loads and details about the loads are given, so that in step 1, write down the data given. Then step 2, calculation of area required as per the permissible or allowable stress, that is sigma AC, which is equal to 80 megapascal. Hence, we can determine the area required, which formula is load by allowable stress or permissible stress. Then step 3, here find out suitable section as per required area value in IS code 1161-2014 and table number 1. So here your A required should be less than A provided, and this condition should be satisfied in this step. After that, write down the properties of the suitable section from the IS code 1161-2014. Then in step 4, find out the slenderness ratio, which is equal to L by R, where L is the effective length of the compression member, and to determine the value of effective length, we need to know the conditions according to the table number 7 in IS code 806-1968, and R is the radius of gyration, which is given in the 1161-2014 code. Then in step 5, we have to find out the permissible axial stress, that is FC, from table number 2 in IS code 806-1968 by the help of interpolation method. Next one is your step 6. Here, calculation of safe load carrying capacity we need to calculate. So P is equal to FC into area. And lastly, the value of P should be more than load of compression member. If this condition is satisfied, then we can say the structure is safe. The next part of this truss is design of tension member. So these are the procedure for design of tension member. So first of all, in step 1, write down data given as load of tension member and grade of the tubular section is given in question. Then step 2, assume that permissible tensile stress, that is gamma ST, from table number 1 in IS code 806-1968 according to the given grade of the tension tubular section. Then step 3, that is calculation of area required as per the permissible or allowable stress, that is sigma st, and find out A required is equal to load by allowable stress, that is sigma st. The next step is step 4. Here find out suitable section as per area required value in IS code 1161-1014 table number 1. Here A required should be less than A provided, hence it is satisfied. Then write down the properties of the suitable section from 1161-2014. Next one is your step 5. Here calculation of length of intersection, that is denoted as L. Outer diameter of main tube or tension member, that is denoted as small d, is found out from the 1161-2014 as per the properties of the suitable section. Then capital D is your outer diameter of the secondary tube or compression member. Then theta is the angle of intersection, which is already given in the question. Hence, we can calculate the length of the curve of intersection by the formula which is already given in the code 806-1968 Appendix B. So the formula is small a plus small b plus 3 into root over of a square plus b square, where a can be calculated by the formula small d by 2 cosec theta and b can be calculated by the formula d by 3 into 3 minus small d by capital D square divided by 2 minus small d by capital D square, which is already given in IS code 806-1968 in page number 18 to 19. The next step is step 6. Here calculation of connection or weld joint. So find out the area by load by permissible maximum shear stress. So permissible maximum shear stress, that is denoted as tau max, as per the grade of the tension member we have to choose. Then load is already given in the question. The area of the tubular section is calculated as LW into T, where LW is the length of the welding and that is also known as length of the curve intersection. Then small t is the effective thickness of the weld. So by equating load by tau max is equal to LW into small t. So here T can be found out. After that, as per the welding connection, we know that effective thickness of the weld, that is TE or T, is equal to K into S. In general case, we take K equal to 0.7 due to the angle between fusion phase. Hence, S can be calculated by S equal to T by K. Here, the table 2 represents the permissible axial stress in compression member, which is already given in IS code 806-1968. So here is your first column slenderness ratio, the second column grade of the tubular section YST210, and third column represent grade of tubular section that is YST 240, and third column represent the tubular section grade of YST 310. Now comes to a numerical on tubular section. So today this much. We will continue from this numerical in the next class. Thank you so much.